I'm going to present the installation of Avidian SafeKit, including the installation of the package, configuration of nodes in the cluster, and the upgrade procedure. Let's start with an overview. To install and configure Avidian SafeKit, follow these steps. In Step 1, install the SafeKit package on all SafeKit nodes. In Step 2, configure the SafeKit nodes by setting up security settings and license keys. In Step 3, configure the SafeKit cluster by specifying the nodes in the cluster. In Step 4, configure a SafeKit module by deploying either a mirror or a farm module. Steps 1 and 2 are explained in these slides, while Steps 3 and 4 are detailed in the SafeKit web console or command line interface slides. Let's start by analyzing the prerequisites before installation. Let's review the prerequisites for installing a mirror module. In Step 1, ensure that the operating system is either Windows or Linux, and that all nodes are running the same OS and version. It is also important to align the clocks. This ensures accurate log analysis and proper file management across the servers. In Step 2, for the application, make sure it is installed with the same settings on all nodes. Additionally, disable the automatic start at boot of the application. The application start will be managed by the automatic start at boot of the module. In Step 3, for the network, ensure that all nodes are on the same IP network if using a virtual IP. If possible, set up a dedicated replication network to enhance performance. In Step 4, for file replication, ensure that the replicated directories have the same path on all nodes. On Linux, align the user IDs and group IDs. On the schema, you can see the principle of a mirror module, which operates in the prim second state. Each node has its own physical IP address, IP1 and IP2. The virtual IP is configured by SafeKit on the network interface of the prim node only, as an alias IP address. Clients connect to the virtual IP and are routed to the prim node. The application is started by SafeKit on the prim node using a start script. The folders to replicate are synchronized in real time and synchronously, with only modifications inside files being replicated. Let's go over the prerequisites for setting up a farm module. In Step 1, for the operating system, ensure that you are using either Windows or Linux and that all nodes are running the same OS and version. If you're using Linux, make sure to install the kernel compilation tools for the VIP kernel module. It is also important to align the clocks. This ensures accurate log analysis across the servers. In Step 2, for the network, all nodes should be on the same IP network if you're using a virtual IP. In Step 3, for the application, install it with the same settings on all nodes and disable the automatic start at boot of the application. The application start will be managed by the automatic start at boot of the module. On the schema, you can see the principle of a farm module, which operates in the up state. Each node has its own physical IP address, IP1 and IP2. The application is started by SafeKit on both nodes using a start script. The virtual IP is configured by SafeKit on the network interface of each node as an alias IP address. Clients are connected to the virtual IP, and their TCP sessions are load balanced between Node 1 and Node 2, thanks to a VIP kernel module. Let's examine how to install the SafeKit package. Let's go over the steps before installing SafeKit. In Step 1, download the SafeKit package from the Avidian site. In Step 2, make sure to check the free disk space. You'll need 97 megabytes for the installation directory and 3 gigabytes per module for the var directory. In Step 3, for Windows, the installation directories are in the C drive. For Linux, the installation directories are in /opt and /var. A command line interface is provided on Windows and Linux, and all the commands are prefixed by the SafeKit command followed by parameters. A web console is also provided and can be accessed from a browser on port 9010. In Step 4, for any help, review the 3 main documentation. The user's guide contains all technical information. The software release bulletin gives an up-to-date list of supported operating systems and a list of fixes. The SafeKit release notes details migration instructions and major changes. Let's examine the package installation and start with the installation of the Windows package. As an administrator, you will need to double-click on the SafeKit Windows.msi package to begin the process. At the end of the installation, A window displays a checkbox with the message, "Set console credentials and firewall rules now." Check the box, enter a password for the admin user, and assign the same password on all nodes. Let's move on to the installation of the Linux package. As root, you will need to make the downloaded safekit linux.bin file executable. Then, execute the file to start the installation process. It will extract the package and the safekit install script. Run safekit install, reply yes for firewall automatic configuration, enter a password for the admin user, and assign the same password on all nodes. Now let's move on to the installation of the modules. First, choose a module from the list provided on the Avidian site. Each module comes with a quick installation guide and a free trial. Once you have selected a module, copy the .safe file to the generic directory. A .safe file is essentially a zip file that contains start and stop scripts, as well as a configuration file named userconfig.xml. Let's now examine how to configure the nodes in a cluster. Let's talk about the SafeKit services installed on each node. The SafeAdmin service runs the SafeKit framework. It manages the start and stop of modules, with each module having its own processes for real-time replication, virtual IP, and failover. On Windows, it operates in the local system account without a password, while on Linux, it runs in the root account with a password. For commands, on Windows, you can use netstart or netstop to control SafeAdmin. On Linux, you can use systemctl start or systemctl stop for SafeAdmin. The Safe Web Server service runs the Apache server, which is required for the web console, the global SafeKit command, and the module checker. On Windows, it operates in a virtual account without a password, and on Linux, it runs in the SafeKit account with a locked password. For controlling Safe Web Server, you can use the SafeKit Web Server start, stop, or restart commands. At boot, SafeAdmin starts, followed by Safe Web Server, and then SafeAdmin starts the modules configured to start at boot. At shutdown, SafeAdmin stops running modules, then SafeAdmin itself stops, as well as Safe Web Server. Let's discuss the firewall setup for SafeKit. This involves adding SafeKit firewall rules for both Microsoft Windows Firewall and Linux Firewall D or IP tables. The firewall configuration is important for web console communications, for communications of the SafeKit framework between modules, and executing global commands. For Windows, since SafeKit 8.2.3, and for Linux, no action is required if the firewall automatic configuration was accepted during the installation. For a manual setup on Windows, open a PowerShell as an administrator on each node and run the command firewall cfg-add. On Linux, open a shell as root on each node and run the same command firewall cfg-add. You can reapply this command multiple times without any consequences. For other firewalls, refer to Firewall Settings in the SafeKit User's Guide where the list of processes and the list of ports used by SafeKit are described. Let's discuss the setup of the SafeKit web service. This process involves initializing the user admin with its password for the web console and activating the global SafeKit command. For Windows, since SafeKit 8.2.3, and for Linux, no action is required if the password initialization was done during the installation. Now, let's move on to the manual setup. For Windows, open a PowerShell as an administrator on each node and run the web server cfg command to set the password. For Linux, open a shell as root on each node and run the same web server cfg command to set the password. You can reapply this command to reset the admin password. Please note that the admin user's password should be identical on all nodes. Otherwise, the web console and the global command will not work. This is the minimum setup required. For advanced authentication on HTTPS, please refer to Securing the SafeKit web service in the user's guide. Let's discuss the setup of antivirus exclusions for SafeKit. In some cases, due to SafeKit's close integration with the operating system, it may be necessary to configure the antivirus to exclude certain directories to ensure smooth operation. Let's talk about the directories that need to be excluded. For Windows, exclude the SafeKit directory in the C drive, which contains the binaries and the var directory. On Linux, exclude the SafeKit directory in /opt and /var. Additionally, all replicated folders defined in mirror modules should be excluded. For more information, Please refer to antivirus settings in the SafeKit User's Guide. Let's talk about the SafeKit license key setup. Firstly, let's discuss the free trial license key. Without a license, SafeKit will start, but will stop every 3 days. To avoid this, you can get a free 1-month trial key for any hostname and any operating system on the Avidian website. Secondly, for those who have made a purchase order, you can obtain a permanent license key based on your hostname and operating system at the Avidian website. Thirdly, let's move on to the license installation process on each node. Follow these steps. Copy the license key file into the safekit/conf directory. Then, check the license with the web console or by using the command safekit level. Let's now examine how to make an upgrade of SafeKit. The upgrade procedure involves 3 important steps to ensure a smooth transition. Firstly, before upgrading, check the list of fixes in the software release bulletin and read the SafeKit release notes for migration instructions. You can select your version of SafeKit on the Avidian website. Secondly, let's start with the uninstall of the current package. Stop all running modules by executing the command safekit shutdown. For Windows, to uninstall the current SafeKit package, use the control panel to add remove programs. For Linux, to uninstall the current SafeKit package, run the command safekit uninstall. Please note that the main configuration files, cluster, module, license, etc., are not removed during this process. Thirdly, proceed with the installation of the new SafeKit package. Download and install the SafeKit package from the Avidian support website. If it is a major upgrade, apply the migration instructions as specified in the release notes. 4 versions before SafeKit 8.2.3. Run the manual firewall setup in Windows. 4 versions before SafeKit 8.2.1. Reapply the module's configuration using the command safekit config with the module name as parameter. Before using the web console, make sure to clear the browser's cache by holding Ctrl and Shift while tapping the delete key. Let's consider a minor upgrade fixing the same version of SafeKit and ensuring a smooth transition with minimal downtime. At step 1 in the figure, the cluster to upgrade is running prim-second. At step 2, we stop node 2, upgrade it, and then restart it. During the upgrade of node 2, the application is not interrupted and runs on node 1. At step 3, the module is started on node 2 and has resynchronized application data. At step 4, we stop the module on node 1. Then there is an automatic restart of the application on node 2, resulting in a downtime associated with this restart. If everything works well on the upgraded node 2, then node 1 can be upgraded. If something is not working correctly on node 2, it is possible to make a rollback by stopping the module on node 2 and forcing the start as primary on node 1 with the old version before the upgrade. At step 5, after the upgrade of node 1, we can start the module on node 1, which resynchronizes the application data before becoming secondary. The cluster is then upgraded with a minimum downtime associated with the restart of the application at step 4. Let's now consider a major upgrade involving a change in the SafeKit version. At step 1 in the figure, the cluster to upgrade is running prim-second. At step 2, we stop the entire cluster, starting with node 2, to avoid an unnecessary failover. Then, we upgrade node 1. At step 3, we restart the module on node 1 and check that everything works well. If it does, we can upgrade node 2. If not, we can stop node 1 and force node 2 to start as primary with the old version before the upgrade. At step 4, after upgrading node 2, we restart the module on it. Node 2 resynchronizes application data before becoming the secondary. The entire cluster is upgraded with downtime limited to the upgrade of node 1 at step 2. Thank you for your attention. If you have any questions or need further clarification, please feel free to ask.